In Chapter 4, we move on to look now at trig functions. And in this chapter, we do two things. The first thing we do is look at introducing another way of measuring an angle, and that's called using radians. The reason that this is introduced is because it's fundamental to proving the derivative of trig functions, in that we express the angles in terms of radians. However, for you, it's not essential that you know the derivation of the derivative, but it is important that you are familiar with the fact that there is another system for measuring angles, because not only is it essential in, like I said, showing the proof for the derivative of trig functions, it also allows some other calculations to be made more simply. So we're going to look at calculating arc lengths, we're going to look at calculating areas of segments and sectors. However, the understanding will be you will only use the formulas that you will be introduced to in this chapter if the angle given is measured in radians. Now we'll see how to convert from degrees to radians, such that if the angle wasn't given in radians, you could convert it from degrees to radians and then use these formulas. So that's one part of the chapter. Then the second part of the chapter, which covers many exercises, looks at the calculus of the trig functions. So we're going to look at differentiating the trig functions and integrating the trig functions. And again, there'll be applications of both the derivative and integrals, but they will be similar type problems to the problems we've seen in the past for application of derivative and integration. So 1 radians, 2 calculus. So just a little bit about these radians. Obviously they measure the size of an angle. Now this measurement system is based on the concept of a ratio. So it actually doesn't have any units. A radian is just a radian. It is a ratio, and the symbol that we use, if a symbol is even used at all, it is this little C in the in the position that the degrees symbol would normally be. Now, it will become the universal unit for angles. So that means if you want to talk about an angle being measured in degrees, you must use the degree symbol, because otherwise an angle is understood to be measured in radians. So while you, for the majority of your maths course over the years, have used degrees for measuring angles, this is not the universally accepted unit, nor is it the unit that most real mathematicians would use. They would be measuring angles in terms of these radians. So like I said, a radian is a ratio or a fraction. Easiest to understand it when it's written as a fraction, and the fraction is made up of the arc length over the radius. So you can see here the arc length is this, and the radius obviously is the radius for this particular size angle. Now that particular size angle has, when the circle is of this size with this radius, the ratio of that arc length to that radius would actually give me the size of the angle in radians. The interesting thing is, it doesn't matter how small we actually make the circle. So I change the size of the radius. If I still keep the same sized angle here as here, these two are the same. What's interesting is this arc length now, which is obviously smaller than AB, over this radius, which is obviously smaller than that radius, that ratio of arc length to radius in this situation, so let me call that L2 over R2, that L2 over R2 is exactly the same as AB over R. They're exactly that, they simplify down to exactly the same number or fraction. So, why? Because they're exactly the same sized angle. Now, you know that you could draw the same sized angle in degrees, in different sized angles, and it still looks the same size, same concept. Things we know about 1 radian is, based on this definition, that it's arc length over the radius. If I talked about 1 complete revolution, then think about the arc length of 1 complete revolution, and it would be the length from A all the way around to A over R. However, we know that as the circumference. And the circumference we know is calculated, or the length of the circumference is 2 pi r. We have this ratio 2 pi r over r, which simplifies to simply 2 pi. Cancel the r's. So we've got that 1 revolution, which we would normally call 360 degrees, is 2 pi radians. Exactly the same. This gives us our connection between degrees and radians. Halving both sides, we would have the pi radians is 180 degrees, and we will want to be able to get an expression for 1 radian, so dividing this by pi to get it down to 1, and we divide this side by pi to get to, because what we do to one side we also do to the other. So we actually end up with 1 radian is 180 degrees divided by pi. Now we know that that is going to be approximately 180 degrees divided by 3-ish, because pi is almost 3, and that then in turn would be approximately equal to 60 degrees. So just very, very approximately 1 radian, that would be where your arc length and your radius are the same length. That works out to be an angle about 60 degrees. So common questions involve converting your, for example, radians into degrees, and to do that you'll simply multiply by this 180 degrees on pi. Where does that come from? It comes from what we just had above, that 1 radian is 180 degrees on pi. So if we should have 10 radians, we want 10 times this 180 degrees on pi. So you simply multiply by 180 on pi. We've also got that to convert degrees to radians, we multiply by pi on 180. You may be wondering where that came from, and remember that we had 180 degrees was pi radians. So if I want 1 degree, or I have 1 degree, then it's pi divided by 180 radians. Now if I then got not 1 degree but say 5 degrees, then I would have 5 times pi on 180 radians. And I would do that calculation to convert my 5 degrees into radians, just like it says here, multiply by pi on 180 to convert degrees to radians. There are some common connections between radians and degrees that I would strongly recommend that you learn, and they include 30 degrees is known as pi on 6. 45 degrees is pi on 4. You can work these out for yourself, and it's all based on the fact that pi radians is 180 degrees. So to get to 30. To get to 30 degrees, I need to divide that by 6 and divide that by 6. 6 into 180 is 30 degrees, and we've got pi on 6 radians. And that's what is stated here. You can go through a similar process to this for all of these. Pi on 4 is 45. Pi on 3 gets 60 degrees. Pi on 2 is 90, etc., etc. Now, the reason that I strongly suggest that you learn these common conversions is because, like I said before, we're going to learn some new formulas. However, those formulas can only be used when your angles are expressed in radians. I saw in last year's HSC exam, questions given where the angles were given in degrees and students had to convert to the appropriate radian measure to be able to use the formula. So please be aware of that. You can see there I've completed the conversion. For these first three, it was converting from radians. Note, no unit given. However, we understand that then to mean radians and converted it to degrees, and you must put the degree symbol on your answer just by multiplying by 180. So please learn these off by heart. To convert radians to degrees, multiplied by this 180 on pi, and you'll see I've done that exact same process. And then in the second part, I've converted degrees, obviously given as degrees, into radians, and in my answer I haven't needed to indicate a unit. I'll pause the video, I'll stop the video there and do the rest of this exercise in another video.